All right, we'll go ahead and get started. Um, Again, keep in mind you can watch this after the fact, so if you miss something, you have to get up. You can always pause this, rewind, do whatever. This is for you guys. All right, so I'm going to do what I normally do. I'm going to go over some topics covered. As I'm doing this, kind of think of questions. All right. Um, After I go over the topics covered, I'm going to actually do a couple of notes over asymptotes just so they're there and I can copy and paste it and kind of drag it around. Um, and then I'm going to go over every problem on the practice test, and I'm going to go over every problem on the last practice test in that topic. Okay, I forgot what it's called right off the top of my head, um, but it's the one that starts with this. This is the last one I gave you. This is the one I actually generated for you guys. So it's not like version 3 or last year's test. It's the one below that. All right. Um, so let's go ahead and get started. So some topics covered, some things that are 100% on the test. Uh, I'm going to go in order of what we covered. So quadratics. Okay, we need to be able to find zeros. We need to be able to find the vertex. So we need to be able to factor. The one thing on here that I kind of forgot to mention was completing the square. So to go from a quadratic in standard form to one in vertex form, we have to go complete the square, which we'll do here in a second. Okay, but we need to be able to find the vertex given any form. All right, there's different ways to do that. I actually don't think I ask anything about the vertex, so you probably don't even need to worry about that. But we do need to know vertex form. Then we need to know end behavior, so we need to be able to pull out the degree of any polynomial and the leading coefficient of any polynomial. And then from that, we need to be able to get the behavior on both sides, both ends of a graph. Okay, and that'll help us graph along with a whole bunch of other stuff on here. All right, we need to know about the intermediate value theorem. All right, and that's going to come into play. Like, I'm not going to ask you a specific question about the intermediate value theorem, but I am going to ask you to graph a polynomial function, and it requires you to at least understand the concept, right? So what this says is that the only way there's a zero on a graph is if we go from the negative side of the graph, right down here, to the positive. So there has to be some kind of sign switch. That's the only guarantee of a zero, right? So if there is no sign switch, then there's not a guaranteed zero. If there is a sign switch, there absolutely has to be. Okay, and I'll explain kind of what that means. Rather, I have explained it before. I'll re-go over it, what that means here in a couple minutes. All right, you need to know a little bit about polynomial inequalities. The last question on this entire test is a polynomial inequality. Again, it's basically just like solving for an asymptote, but we're putting it on a number line and kind of testing different intervals. All right. We need to know division, so we need a long division of polynomials as well as synthetic. Both should be pretty straightforward. And then we need to be able to rationalize functions using square roots, conjugates, and imaginary numbers, right? So basically rationalizing with any of those things in the denominator and then using conjugates to do that, okay? And then asymptotes. Asymptotes is one of the last things we went over. And again, I'll put those rules up here in a second, but we need to know how to find vertical, how to find horizontal, how to find a slant, and if there are any removable. I'm not super worried about removable discontinuities, but it's at least helpful to know. That's what my calc guys are going over right now, so it is helpful to know. Yeah, so I'm going to put those notes up. I'll scroll to the right. Actually, right here will do. Okay, so I'll just do this real quick. I won't like explain most of this stuff, so give me a minute to write this down, and then we'll start to do the actual test. Okay, so really quickly, just so you guys can hear this as well as read it. Different kinds of asymptotes. The easiest one to find is the vertical. All right, so for the vertical asymptote, you set the denominator function equal to 0, and you solve. At those values, there is going to be an asymptote. Okay, unless you can factor one out, in which case it's removable, but right now I'm not really worried about that. Okay, horizontal asymptotes. You can get horizontal asymptotes by finding the degrees of the numerator and denominator and comparing them. If the degree of the numerator is greater than the degree of the denominator, or sorry, is less than the degree of the denominator, we have an asymptote of y equals 0. If the degrees are equal, our horizontal asymptote is just the ratio of the leading coefficients. And if the numerator degree is greater than the denominator degree, there are none. Okay, and then if there's a slant, if the numerator is exactly one more than the denominator, and then you find that using long division. All right, you will see this once we do it, but this was probably the most like content heavy of the pieces, and I just wanted you to see it one more time. Everything else is kind of conceptual, and if you get one concept, you get it. These asymptote stuff, it requires a little bit more just like memorization. All right, so this is the most like memorizing part of the test. Okay, these should all make sense if you really think about it. You can never have the denominator equal to 0, so that's when you're going to have a horizontal asymptote, or sorry, a vertical asymptote. If the numerator is less than the degree of the denominator, when you divide out the denominator, right, nothing's going to be left on the numerator. And then if they're equal, right, eventually you're going to factor stuff out such that the only thing that's left are the leading coefficients. Okay, and then if the numerator is greater than the denominator will just kind of disappear, and then things will be factored out, right? So I don't want to confuse you on that right now, but if you really, really think about this stuff, it should make sense. Okay, but let's get on to the test. Okay, so first part is to convert the following into vertex form, then label the vertex. All right, so 2 parts. Convert to vertex form, and then find the vertex. Okay, so as soon as you get into vertex form, you pretty much have your answer. You just got to pull this stuff out. In order to do this, you need to complete the square. All right, so when we complete the square, we're just focused on our green box. I can use highlighter. Okay, so what we're going to do is we're going to take that -8 inside the highlighted part. We're going to divide it by 2. And then we're going to square that. And we want to add this value inside the green. And because we add something to the left on the left-hand side of the equal sign, we also have to add it to the right. Then we factor the thing on the left. We get n minus 4 squared. And then we just get everything to the left. And then your vertex is just this 4 and this -91. So a vertex is 4, -91. And that's full points. All right. So again, you complete the square, you factor that out. You factor it get everything to the left, and then just use vertex form. Okay, so we'll do the same on the other problem. What we add on the left-hand side, we have to add on the right-hand side, and then we just work on factoring. And just as like a kind of a reminder, you're always taking the opposite of what's in the inside. You're not just taking positive 8, you're taking the opposite of this value. So if it's negative, part of your answer is going to be positive. Jack, what's your question? So guys who are remote, you'll be taking it online. So I'll have an upload for you. You do it on some loose leaf or computer paper. You take pictures of it. You submit it that way. All right. So next couple of questions. Describe the end behavior of the following functions. These should be very, very simple give me points. I'm looking for the degree, and I'm looking for the leading coefficient. Right. So in this case, the degree is 4. Which is even. The leading coefficient is 1, which is positive. Okay, these two things tell you what the end behavior is, right? So in really formal terms, I'll start informal. It's a little bit easier to explain. Right, so your answer can just look something like that, right? Those two solid lines, that's the answer that I'm looking for. So as x approaches infinity, f of x is also approaching infinity. And as x approaches negative infinity, f of x still approaches positive infinity. Okay, you can do either of these things. Honestly, it probably makes more sense because it's a lot easier to do just to do this. But if you really want to work on your notation here, go for it, so long as it's right. All right, we didn't really practice that box part a whole lot, but I'm really just worried about that you know what it looks like. All right, same thing for the second one, right? Our degree is 3. We still have a leading coefficient of 1. Our degree is odd. Our leading coefficient is positive. So when we draw this, we're going to start down low and end up top. And again, if you wanted to write this in kind of formal terms, as x approaches positive infinity, so as x goes way to the right, f of x will also approach positive infinity. As x approaches negative infinity, the opposite happens. So as you go left, f of x goes down. And then on the last one, our degree is 8. it's even. Our leading coefficient is still 1, which is positive. You will most likely have 1 where it's negative. I'm not sure why there isn't 1 on here. But I would definitely plan on having a leading coefficient that's negative and not just 1. All right, so if we drew this, it would look a lot like the first one. Right, it rises on the left and on the right. So as x approaches positive infinity, f of x also does. And as x approaches negative infinity, f of x still goes up. All right, so that's end behavior stuff. These ideally are probably the easiest ones on this test. All right, because really all you're doing is pulling two things out, and then you're describing basically the looks of either a quadratic or a cubic. And if you can do those two things, these should be decently easy. All right. So the next one, this is like the chunkiest part of the test. Do we need the notation off to the side? No, you don't need the notation. Right? If you just draw this, that's fine. The notation, that's what you're going to be seeing kind of in the near future, in the next year or so, once you get to limits and derivatives and stuff like that. So it's good to at least know that exists and what it means. But I'm not like, if you don't do that, I'm not going to take off points. All right. So again, number 6, this is kind of like the meatiest part of this test, at least in terms of like point values per question. This is pretty heavy. All right. So this says graph the following function using end behavior, the intermediate value theorem, and finding the zeros. Are you going to talk about linear inequality problems? It doesn't say it in the description. Polynomial inequalities. Yes, that's the last. That's like the last problem on this test. And yes, I will go over it. So again, graph using all of this stuff. So I ran through exactly what I was looking for last class. So I'm going to do that again today and just kind of model it. All right. So the first thing that I would do is get the degree and the leading coefficient. The degree in this case is 3, which is odd. The leading coefficient is -4, which is negative. Simple. That's easy points right there. If you do that, you're going to get some kind of partial credit. All right. Again, just knowing degree and leading coefficient, what those two things are, and being able to pull them out of an equation is worth something. Okay. The next part is a little bit trickier. All right. So that's going to be the zeros part. Okay. So if we just find the zeros of this entire equation, you should notice that we can pull out a 4x from all this stuff. And I'm going to pull out a -4x. And when we do that, we're left with x squared minus x minus 6x. Or sorry, minus 6. So either -4x is going to equal 0, or this thing is going to equal 0. Both of which we should know how to do, right? Right, so -4x equaling 0, that's really easy. We set that equal to 0 and solve. So that's one of our answers. The next one probably isn't super obvious at first, but once you realize it's a quadratic and you set it equal to 0, right, you can either factor it or use the quadratic formula. So if we do this, we can factor that green part into x minus 3 times x plus 2. We set each of those things equal to 0. get 2 more zeros. All right, so that's the second part. That's finding zeros. That's a pretty chunky part of the points on this problem. And the rest is really just graphing it. Right, there's the intermediate value that kind of comes into play, but you're kind of using it in the background. So the first thing we do is we plot our zeros. So we have a 0 at 0, x equals 0. We have a 0 at negative 2. And we have a 0 at positive 3. All right, so we plot those, and then on both sides of those things, we determine the end behavior from this red part. Okay, so we know it has to start up top, and it has to end down bottom. And then everything in between we need to check, right? So we need to check, let's say, this value and this value. And when we check those, it'll tell us what's happening in between here and here. Okay, so if we plug in f of 1, use a darker green. When we do that, so this should be negative 1. All right, so this is going to be a positive 4. So 4 minus 4, that's 0, minus 24, that's negative. All right, so f of negative 1 is a negative value. And what that tells us is by the intermediate value theorem, we know that every point within that interval between these two zeros has to also be negative. So our graph kind of looks like this. I'm going to make this a little bit neater. All right, so we tested that left interval. Now we need to test the right interval. So we plug in a number like positive 1. And this is going to give us a positive value. Right, so our graph has to go up and then come back down. So our graph is roughly going to look something like that. Okay, so within this, we found the degree and leading coefficient, which tells us everything in red. We found the zeros, which tells us the blue points. And then we use the intermediate value theorem, which gives us everything in that dark green. Okay, you have to use every piece in order to get the full credit. Okay, so I'm going to leave that up there for 10 to 15 seconds, and then we'll move on to the next problem. Okay, zeros. All right, so the zeros is everything in blue. Okay, so when we're finding the zeros, normally it's going to come down to factoring something out and then either factoring again or using the quadratic formula. All right, so within negative 4x cubed plus 4x squared plus 24x, right? There's a common factor between all three of those terms, right? And that common factor is 4x or negative 4x. I like to pull out the negative just because it makes my life easier a little bit later on. All right, so if we pull out negative 4x from each of these terms, we're left with positive x squared minus x, and then minus 6. And when we're finding the zeros, we're setting these things equal to 0. Okay, so now what we have is we have two factors. We have negative 4x, and we have x squared minus 6x minus x minus 6. Okay, so in order to get so if two factors equal 0, either the first factor has to equal 0 or the second factor has to equal 0. So negative 4x is equal to 0, which is really easy to solve, right? Just x is equal to 0. Or x squared minus x minus 6 is equal to 0. Okay, which that's just a quadratic. You can either use the quadratic formula or you can factor it. In this case, factoring is super easy, right? We need factors of negative 6 that add up to negative 1, which end up being x minus 3 and x minus 2. And then we just apply that same 0 concept. One of those should be a positive. All right, so when we do all that, right, when we factor it out the first time, we get x equals 0. And then if we continue to factor, we get these two things. All right, I'm hoping that answers your question. Yes, x plus 2, right? When you factors of negative 6 that add up to negative 1. Negative 3 plus positive 2, that's negative 1. Regardless, we factor this to get these two. We set each of those factors equal to 0, and we solve them. All right, great. So that's like the chalkiest problem on this test. If we get that right, you really understand most of the concepts. So yeah, all right. Next is division. I'm going to make you do one long division and then two synthetic. Okay, so for long division, we set up kind of like we would when we did long division with regular numbers. And we're really seeing how many times this first term goes into each of these. Wait, you only have n minus 1 zeros. Don't worry about that rule. All right, it's true, but I think it's a little bit confusing. If you just focus on factoring as much as you can, you're going to get the right answer. Right, so in this case, we have 3 zeros. I think there's n minus 1 turns, right? So there's n minus 1 going from like increasing to decreasing. Okay, but for this long division, we're looking to see how many times 10x goes into each one of these terms, right? So we ask ourselves how many times does 10x go into 10x cubed? All right, so what times 10x is equal to 10x cubed? And the answer to that is just x squared. Right, so we multiply x squared by each of these two, so we get 10x cubed plus 3x squared. And then we subtract. So our first term, those subtract, get 0. 93x squared minus 3x squared, that's just 90x squared. And then we repeat that process. So many times is 10x going to 90x squared? The answer is 90x. Sorry, 9x. And then we multiply that out after we bring down that next value. Subtract. And repeat. All right, so 10x into 80x, that's plus 8. So we get 80x plus 24. We subtract those two things, and we get just negative 3 left. And this negative 3 is our remainder. So with that remainder, we do minus 3 over this divisor, which is 10x plus 3. All right, so this is our answer. All right. Synthetic makes this a little bit easier. You take this thing on the right, you set it equal to 0, and you're dealing with this number. So you draw the box, and then put all the coefficients. All right, so we bring the first value down. We multiply the first value times what's out here, so we get negative 15. And then we add it down. Right, so 10 plus a negative 5, that's negative 5. Then we multiply up to get positive 25, and then add down to get negative 10. Multiply up to get 50, add down to get 0. Okay, so our answer then is 1 degree lower than our original polynomial. So this is 3x squared minus 5x minus 10. Same thing over here. We bring our first value down to get 1, multiply across to get negative 4, add down to get 2, multiply up to get negative 8, add down to get negative 6, multiply up to get 24, and then we have a remainder of negative 5. So our answer again is 1 degree less, so we have n squared plus 2n minus 6, and then this remainder over n plus 4. Okay, so I went through those kind of quick. Again, take a look at it, make sure you understand how to do it. If you don't, please ask. Then we're simplifying or rationalizing. These first two problems should be very, very simple. We're just combining like terms, right? So we have 5 plus a negative 2. That's just negative 3. Sorry, positive 3. Can't add. And then positive 4i minus 2i. It's plus 2i. Same thing over here, except this time we're multiplying. We FOIL, we get 25 plus 50i plus 25i squared. So this is 25 plus 50i minus 25, right? Because I squared is negative 1. So we just get 50i. For rationalizing, again, we can't get anything we can't have anything in the denominator. All right, so we need to multiply by different clever forms of 1. All right. For this number 12, the easiest way to do that is just multiply by root 34 over itself. When you do that, you get 10 root 34 minus root 170 all over 34. And this is fine for an answer. I'm not really worried about you simplifying that. Ideally, you should be able to simplify like root 34, but I don't think there's going to be a common factor. So that works. All right. Same thing for the i's. So for this problem, 2 over 6i, I would just multiply by I over I. When we do that, we get 2i up top, 6i squared on bottom, which is 2i over negative 6. And again, if you wanted to simplify, you could. That's just negative 1/3 I. Negative I over 3. That works. All right, so that gets the radical out of the denominator, and then it gets the square, the imaginary number out of the denominator. 14 is where it gets a little bit trickier, right? So we have a sum in the denominator. So whenever we have that, we need to multiply by that conjugate. So we need to multiply by 8 minus I over itself. Right, so when we factor that up top, when we FOIL that up top, we get negative 64 plus 8i plus 16i minus 2i squared. And on bottom, we just get 64 minus I squared. Then we got some simplifying to do, so we have negative 64 plus 24i plus 2 all over 64 plus 1. And we get negative 62 plus 24i all over 65. All right. Next is the asymptotes, and then I think there's 3 of those, 4 of those, and the polynomial inequality. All right, so each one is one example of a question that I want you to be able to see and understand, right? So this first one is just, it has one asymptote. All right, so in order to find that vertical asymptote, which is the first thing you should be looking for, we just set that denominator equal to 0 and solve for x. So we have an asymptote at x is equal to negative 3. So we draw that in there, and then we need to see if there's a horizontal asymptote. Right, so in this case, the degree of the numerator, that's 0. Degree of denominator, that's 1. So our numerator is less than our denominator. So we have a horizontal asymptote at 0. And then from this, we can graph it. So we need to see what's happening on both sides of our asymptote, of our vertical asymptote, and see if that's above or below our horizontal value. All right, so we can plug in 0. That's going to give us negative 1/9, which is below our horizontal asymptote. So our graph is going to look something like that on the right. Then we need to test the left, so we can test negative 4. So when we do that, we just get 1/3. 1/3 is above our horizontal asymptote. So our graph looks like that. Right, and that's it. Okay, so you find the vertical, you find the horizontal, and then you test the different intervals. Right, so in this case, we're testing everything to the right of the asymptote, and then everything to the left. And we're comparing that to that horizontal red line. For number 16, it gets a little bit more complicated. So what I would like to do, I'm just going to make this a little bit simpler. And actually, no. Well, yeah. I'm going to rewrite this. You don't necessarily have to do this. I like to do this just because sometimes it clears some things up. Okay, and we do the same thing. We find the vertical asymptote first. All right, in order to do that, we set our denominator equal to 0. So the only thing that can make this entire thing 0 is x is equal to 3. Then we find our horizontal if there is one. So in this case, our numerator is 2. Our denominator is 1. So that means we have a slant, right? The degree of the numerator is exactly 1 more than the denominator. So we don't know horizontal, but we do have a slant. In order to find that slant, we just carry out this long division. All right, so we ask ourselves how many times is negative 4x going to x squared? That is negative 1/4 x. Right, negative 1/4 x times negative 4x is positive x squared. All right, so when we multiply this by our denominator, that gives us x squared minus 3x. Yes, all right. So negative 4x goes into 5x. uh, 5/4 times, I guess. Yeah. Okay, this part really doesn't matter because this is all we're looking for. So that is the line we're drawing. So a little bit over 1, that's our y-intercept. And then we're going down 1, left 4. Okay, that's a little bit confusing because there's some fractions involved, which makes things a little bit harder. But we still should be able to do that division. All right. So then we need to test to the left of the asymptote and to the right of the asymptote. All right. So to the left, we can plug in something like 0. All right, so we want something to the left of the red. That's equal to 0, which is going to be above our blue line, right? So our graph is going to look something like that. All right, and then we test something to the right of 0. So let's plug in 4. That's -6. That's going to be above, or sorry, that's going to be below our slant. So then our graph on that side will look like this. All right, again, a little bit more confusing because there's a slant, a little bit more confusing because there's some fractions involved. The concept is still the same. Find the vertical asymptote, find if there's a horizontal or slant, and then graph to the left, graph to the right. Right, when you're graphing to the left, you figure out you take some x value to the left of your vertical asymptote and see if you get above or below your horizontal. To test the right, you do the same thing but to the right of your vertical asymptote. Okay, so again, a lot of steps, but it should be pretty straightforward to do. Isn't the slope negative for that one? Yeah, I drew it wrong. Yes. So for the sake of this problem and not confusing people, let's pretend that this was positive and this was positive. So that means this is positive. All right. Because I don't want to like go back and yes, you are absolutely right, which would change things a little bit. I think the graph then would be probably to the bottom left and top right. So if you did that, you did it perfectly right. I just screwed up a negative somewhere along the way, and that's where I went wrong. So again, a lot of places to go wrong. That's my bad. But for the sake of not confusing people, let's just pretend that those two things are positive. I hope that's okay. I can go back and do that in a little bit, but same idea, same concept. If you did that like on the test, I'd probably take like a half a point off. Just because you did all the work. You did everything right. You're just missing a negative somewhere in there. All right, so let's move on just so we can kind of get through this entire thing. This one down here, this one is going to have two asymptotes, right? And the way you know that is because you have to set your denominator equal to 0. And we can factor that, right? These two have an x in common. So either x is going to be equal to 0 or x minus 3 is going to be equal to 0. So this time we have two asymptotes. We have 0 and we have 3. And then our degree numerator, the degree of the numerator is is just less than the denominator. So we're going to have a horizontal asymptote at y is equal to 0. And then we need to test every interval. So we need to test to the left of each asymptote and to the right of each asymptote. So there are 3 intervals. All right, so we need to test to the left. So let's plug in something like -1. When we do that, we get 1/4, which is above that blue line. So our graph to the left is going to look something like that. Okay, then we need to test in between, so we can test +1. Which is negative, and that's below our blue line. So our graph is going to approach both sides of the asymptotes to the left and the right. I will say sometimes this goes up in between. Don't worry about that, right? So as long as you do all this work correctly, the rest will kind of sort itself out, all right? And then we need to test something to the right, right? So we can test go light blue. We can test +4. That's +4. So we're going to be above the blue line. And our graph, that's the completed graph all the way through. All right. So again, it's a little bit more. There's 2 asymptotes in this, just a little bit different. All right, on to 18. Again, kind of the same idea. You take your denominator, you set it equal to 0. We can factor this. And we have 2 asymptotes. We have a -1 and we have +2. Just like the one above, our numerator degree is less than our denominator. So we have a horizontal asymptote. And again, you kind of do the same thing. You test the left and you test the right and you test in between. So I'm going to do that really, really quick. So let's test -2. Keep in mind there's a negative on the outside. That's negative, so it's going to be below on the left. We need to test in between, so we can test 0. When we do that, we get negative 3 over negative 2, which is just 3 halves, which is positive. That's above the blue line. And then we test to the right. Okay, so I'm going to leave that up for a couple of seconds. If you have questions over that, please let me know. This is, the fourth example. So if you do have questions, please ask. But I don't want to spend all the time on asymptotes, right? We still have one more problem we got to get to. All right, so last problem, solve the inequality. All right, so we want this entire inequality to be less than 0. So really what we need, if you just look at this entire thing, the only values that will make this 0 is when x squared plus 5x plus 6 is less than 0. So what we need to do is we need to see when this is equal to 0. And then we need to test each interval. Okay, so again, this numerator is always going to be positive. So we need values of x that make the denominator negative, which is less than 0. Okay, so we just solve this first. This is factorable like so. So we get those two zeros. All right, and then on a number line, we need to test everything to the left of negative 3, everything to the right of negative 2, and everything in between negative 2 and negative 3. All right, so in order to do that, we can plug in negative 4. I guess really we can just plug that into the denominator. So we have negative 4 squared plus 5 times negative 4 plus 6. That's 16 minus 20 plus 6. This is going to be some positive value. So everything to the left has to be positive. Then we test something in between. Say negative 5 halves. Right, that's 1/2 less than negative 2. Or negative 2.5 if you want to call it that. When we do this, take out my calculator. that's going to give us a negative value. So this will be negative, and then we test to the right. But again, because it's a parabola, you know, it's kind of coming down. It's down below the x-axis, and then it has to go back up, right? So this is the only interval which makes the denominator negative, which is the only thing that makes the entire fraction negative, right? So the values that make our original question negative are x is less than -2, but greater than -3. Right, your answer can look like this. It can also look like this, or like this. All of these are acceptable. All right. So again, this is a little bit confusing because there's a fraction there's a fraction with only stuff in the denominator, and you want to see when that's less than 0. Okay. Do we need to know how to graph it also? No. You don't need to know how to graph number 19. But ideally you do. You do know how to graph it because you would know how to find the asymptotes. You would know how to find the behavior in between those asymptotes, right? So in this problem, there's two asymptotes, one at x is equal to -3, one at x is equal to -2, right? So you're going to have two vertical red lines right next to each other. And you would need to test the left in between and the right, all right? I'm not asking you to graph this on number 19. I'm just asking you for the inequality. But graphing it can help if you're really comfortable with that, all right? No, no, you don't need to shade. No, we never actually shaded in class. And it's great for linear inequalities. It gets a little bit messier when you're talking about quadratics and different rational functions. So I wouldn't worry about that. Okay. So that's the entire test. I want to leave this open for the next 5 minutes at least. And if there's no questions after 5 minutes, then I'll turn this off, and we will take the test tomorrow. Okay, so I'm going to mute myself. I'm going to scroll up from the top, and I'm just going to scroll through it. All right. Every couple of seconds, I'll scroll to the next problem or set of problems, but just so everyone can see what we did. And if you're heading out, no problem. Thank you for coming, and I'll see you tomorrow. All right, since there are no questions, I'm going to end this, and I will see you tomorrow.